Hello Year 6, lovely to speak with you. Not as lovely as if you're in the room, but this is the best we can do for the time being. I just wanted to take you through what a lesson looks like at Melksham Oak. I decided to pick one of my favourite topics, which is space and standard form. So as you can see, I've got a title, I've got a date, I've got some aims that we're going to do today. Now obviously, if you're in the room, I give you the opportunity to write those titles, date and aims down. But today we're just going to go and crack straight in with the teaching. So I thought we'd start off with something simple to begin with. 10 squared means 10 times 10, which is 100. 10 cubed is 10 times 10 times 10, which is 1000. 10 to the power 4 is 10 times 10 times 10 times 10, which is 10,000. And as we can continue the pattern, 10 to the power 5 is 10 times 10 times 10 times 10 times 10, which is 100,000. And what I'm hoping you're seeing from the answers that are on the board so far is perhaps a pattern of zeros. Can you tell me how I would write 10 to the power of 6? That's right, 1 followed by 6 zeros. This is a million, just put my comma in. 10 to the power of 7, I won't do 10 to the power of 8, we're just falling off the bottom of the board. 10 to the power of 7, that's right, again, followed by 7 zeros. Okay, so standard form is going to involve some of these powers of 10. So let's have a little think about it. We now know how we write 1000 in a power of 10. So how might we write 4000? Now you can see I've just split this up. We know that 4000 is 4 lots of 1000. How do you write 1000 as a power of 10? Here it is. So that's going to be 4 times 10 to the power of 3. Okay? Shall we have a little look? 50,000. 50,000 is 5 lots of 10,000. If you remember from the previous slide, 10,000, that was 10 to the power of 4. 1, 2, 3, 4. This number is 7 billion. 7 billion. Let's have a little look. That's right. 7 times 10 to the power of 9. Now, 3,500. Now we've got be a little bit careful with this number, 3,500. Now, and I'll show you on the following slide. The answer to this one is that. Now, I'm sure there are some of you at home shouting that number there. I bet you were, okay? That's the wrong answer. Let me show you for why. Standard form is made up of a number between 1 and 10, followed by a power of 10, okay? And by counting the decimal places, or the zeros, we can find that power of 10. So if we just flick ourselves back, for 3,500, there are 2 zeros, 1, 2, but it's got to be between 1 and 10. So I can't use 35, I've got to use 3.5, which is one more jump, 3.5 times 10 to the power of 3. So this would be the page that we get down in our books. I get you guys to write that down for me and pop it in a box so it's nice and clear and you can use it again in the future. And then we're just going to use these 2 examples. So 20,000, 2 times 10 to the power of 4. Again, I'm sure some of you were already shouting that out at home. And then the second one, 35 million, 3.5 times 10 to the power of 7. Okay? And again, if we're not sure, we can just go 1, 2, 3, 4, 5, 6, 7. So if you're ever unsure, because that's where the decimal place goes, if you're ever unsure what power of 10 it's going to be, those little jumps on the number will really help our way through. Okay? Now, whether we're in the classroom, like on an open evening for a Year 6 visit, or as I'm doing it on the video, I do this a little bit quicker than I normally do in the classroom. Because what we're going to do now is launch ourselves into a few questions. Okay? So what I've done for you is we've got one little exercise at the top, And if you're feeling quite confident with standard form and the way we've been working it, I've got a couple of questions at the bottom for people to think about. Now, absolutely, you feel free. Pause the video, have a little go at these questions, think about what we just did. You guys are in a fabulous position. You can actually rewind me. So if there was something you didn't understand or something you wanted to look at again, you can rewind me and play me again so you can actually answer these questions and work your way through, which is quite exciting. So if you want to pause the video now. And now we can do some answers, okay? So let's have a little look. And if we're doing answers, what I get you guys to do, I can make that just a little smidge bigger for you, is we grab a purple pen and you use your purple pen to tick your answers, and any that you didn't get, we'd use the purple pen to make corrections so that you know which ones in class you got correct, which ones you made a correction on, so when we look back, when we revise, when we do a progress check, you know the areas that you need to work on yourself, okay? And I'll just get out of the way so you can see the answers. I think it's important to have a look about how we go back the other way. So can we go back the other way? So I've got my number, I've got my power of 10, so I know I've got 5, followed by, don't put across multiplication because we're making it a normal number, 5, 10 to the power of 6, 6 zeros, 1, 2, 3, 4, 5, 6, comma from the right, 5 million. Okay? 1.5 times 10 to the 3, 1. Now this is where it gets interesting. This number is not going to have 3 zeros at the end of it. One of those zeros is taken up by the decimal place. So 1, 5, 0, 0. Now that's incredibly important, okay? I'm not just whacking 3 numbers at the end of that number, okay? It takes one of the zeros to move the decimal place, and I've got 2 extra zeros that can go on the end. Perhaps I'll just give you a couple of seconds of thinking time about how you might do that last one. So we've got 3 decimal places before we get to the end of the number. 1, 2, 3, leaving me only 6 more zeros. So 2, 2, 2, 5, 1, 2, 3, 4, 5, 6 zeros. Comma, comma, comma. Okay, 2.225 billion. Okay, so it's really, really important that when we're working back the other way, just like we did going from large numbers to standard form, that we actually count those decimal places and we don't just put zeros at the end of the number. Okay, and again, there's a little exercise for you guys to look at. Again, I am going much quicker than I would usually do in the classroom. And what I'll do is I'll show you some of the things towards the end of this mini lesson that I would use to gauge current pupil understanding. Do we need to do a couple more examples? Do we need to work on some whiteboards? And I can show you some of that towards the end. Again, it's probably well worth having a little look at these. Just have a little practice for yourselves. Feel free to pause the video. And also, again, you can rewind the video if you wanted to see those examples again. So let's do ourselves some answers. Here we go. Again, grab your purple pen, tick your answers, make corrections for those that you don't have, and then we can work on to the next aspect of the lesson. Now, I'm very keen to actually get some of the maths that we do and put it into context, okay? So if we're dealing with very, very, very large numbers, and as you saw, I put the title of today's lesson is to do with space, because basically, we're not just doing standard form for the sake of it. Standard form is there to help us work with very large numbers. Where do you see very large numbers? You see them in the solar system. So, what I like to get people to do is actually kind of work their way through and design me a little kind of map of the solar system. Okay, so what we've got here is we've got the distance from the sun of all the planets. I include Pluto. I know Pluto is a planetesimal, a small planet, but I'm quite old school, so I like to keep Pluto in for old time's sake. Here we've got some further away things. We've got our nearest galaxy, which is Andromeda. We've got the furthest man-made satellite, which is Voyager 1. And we've got our nearest star, which is Proxima Centauri. Now, I've put those values in standard form to be reverted out of it. and I've got these numbers here that are standard form, that aren't standard form, to be converted to standard form. And then what we can do is create ourselves just a little poster of the solar system. Now, to be honest, what I might do is just scroll that down a tad. So at the bottom here, you've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. You've got the colours of what they are. We've got the data. And what you guys could go off and do is design me a little map of the solar system. Pop your values on, pop the standard form in, and we can then work our way through. It's at this point, and I don't usually do this, but I'm just going to grab the camera. I'm just going to take you to one of my displays. And here you'll see some of the work that we've done before on standard form solar systems. And you can see my pictures and how we work them through. So that's kind of what we're aiming for solar system standard form. Okay, I'm just going to now put you back. There we go. And, while you're carrying on, we can just have a little musical interlude. But to be honest, especially for the parents that are watching this, if I'm going to use a song that's got space in, I'm probably going to use The Prodigy. And you get the idea with that, okay? So that would be our application exercise, taking standard form, using what we've just learned, and actually applying it to some sort of real life thing. So the application of standard form is working with space and working with large numbers. And as I was saying, what I'd also do, and this is down here on my PowerPoint. Let me just project that. What I'd also do is use the whiteboards just to be able to judge how people are getting on. Here we go. How people are getting on, so they can write their answers on the whiteboard. You can see I'm starting with a multiple choice answer. You guys feel free at home to join in. As you can see, 9.3 times 10 to the power of 7. I'll just use the keyboard, makes life easier. And again, write that number in standard form. The pupils will have a whiteboard pen and a whiteboard. They'd write their answer on. I count it down. I get them to hold it up. And what that does is just gives me immediate feedback of who's getting it, who may need some more work. We can do a couple more. 82 million. So of course, you've got the decimal place in here. How many people are getting? That's 8.2 times 10 to the 7. We've got a question that's got another 0 in, so I'm looking for 7.06 times 10 to the 4. But again, pupils would write their answer, hold their boards up, giving me immediate feedback on how they're doing. And of course, we go the other way as well. Can you make that a normal number? So I'd be looking for pupils who just put 5 zeros at the end of the number. And again, then I know that's something that we need to work on. So that would be 3, 8, 4 followed by 3 zeros. And you probably get the idea by now. I can do that for that one, and I can do that for that one. Okay, so again, this has been a very whistle-stop tour. It's just been an overview of some of the things that we do, some of the way the lessons work. So we talk about things like explanation, modelling. So you saw the examples that I did of what I would call some fluency practice. So I have just taught you something, can you now do it? You saw from those questions that we had some extension questions on as well. And then we take that knowledge and apply it. And so can we apply it to real life? Can we use it in different situations? Okay, sometimes my application will be a reasoning and problem solving question. Can you answer my question in words? If I tweak it slightly, can you still answer it? And so basically we're developing that knowledge, and then when that knowledge gets to a certain level, can we break that knowledge? Can we give students questions that are harder, that make them think harder a little bit? Okay, And then all the way through, we can use things like mini whiteboards to then judge the level of progress and how people are then working through. Okay? There is a lot more to this, but as a little whistle-stop lesson, I hope you took away a little bit of standard form. Thanks very much for watching. Bye-bye.